Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, everybody, what's up? Sorry, I'm a little delayed today. I was writing a chapter on, what was it? On scientific notation. I have a deadline for UCLA. Well, I'm not working for UCLA. It's like I'm doing consulting work for another company that's doing something for UCLA. But it is for a UCLA course, not one that I'm teaching. So apparently, that's still not a thing yet. Oh, I don't know. Whatever. What a blessing. My ears right now. What's up, Odinru? Good to see you. Yeah, here, I'll show you what I was writing up today. I really do enjoy having ChatGPT like make my life easier, especially like when I have to write homework questions for certain subjects. I'm like, all right, chat, just come up with like 10 like homework questions. I spend like 5 minutes going over them, make sure they're like not absolutely bonkers, which pretty easy for scientific notation, right? And then just I plug them in. Just it lets me focus more on the important things, which for me is like the content, right? So I wrote this whole little chapter today on scientific notation. So, you know, why we love scientific notation. I have this trip called LURD, left up, right down. It sounds like ridiculous, but as I say here, acronyms make things easy to memorize, and it's even better when the acronyms are ridiculous. So then you really remember them. So it's really cool. So yeah, this was all done within Kudu. It's a company I work with, and they're actually the ones that sponsored the Summer Camp Prize, which was a Nintendo Switch 2. Which, congrats, that went to Ethan. I did ship it to Ethan today, so he did win. The rest of yous, I will get you also your $10 prizes later today or tomorrow. Just give me some time. I'm dealing with a lot of stuff, but. Yes, congrats, Ethan. I got to get him a tracking number when I get it, but yeah, I just ordered it today for him. So he should be getting that in the next week. So yeah. All right. Here, let me make sure we're starting on Discord. My bad. And then I'll open this up on YouTube and stuff too. Let's see. I need this to go to this one, this source. This goes here. And then let's make this live. Where's my screen? Oh, there you go. This one. Nice. Okay, cool. Yeah. So today is Monday. Oh, Sib, you text me. Sorry. I will respond to your text. You did text me recently. I've had so much on my phone recently, but yes, I will get to that. Don't worry. I think you wanted to meet next Saturday. Is that what you said? But I'll respond. What's up, Internal? Let's come say hi. What's up, Internal? It was good to see you. Poison Mouse as well. Oh, Poison, you got an E&M question, don't you, or something? What's up, Ramiro?
How you doing?
I'm doing good, dude. How's H-Town? You holding it down in H-Town for me, dude?
You know it.
You know it.
That's dope.
That's cool, dude.
On some real. You know, I'm trying my best not to curse. Can we curse on here or not yet?
You can say whatever the fuck you want. Just don't be like racist or like, I don't know, say homophobic things or whatever. You can say whatever you want. I mean, like within reason. Yeah.
I bet, yeah, because I always try to be careful on here when it comes cursing.
It's okay. I appreciate you being careful, Ramiro. It's great.
Of course.
Nice.
Bro, I swear to God, yesterday, I was so fucking full. We went to Golden Corral.
Oh,
Bro,
Golden. That's a buffet, dude, right? Buffets are dangerous for me, dude.
Yeah, bro.
Absolutely dangerous.
Nah, well, you gotta get your money's worth.
Did you get faded first?
Bro.
I know you got faded
Hell
first.
yeah. You already fucking know it.
That's the worst way to go into a buffet, dude. Because then you got the munchies, man. And you're gonna eat so much until you get sick, dude.
I well, that bro, you gotta get your money's worth.
He is right. You
I
gotta get
swear.
your money's worth. Yeah, but at what
And
cost?
some people
dude?
just don't.
At what
Bro,
cost?
and
Because then, dude,
know,
you're
bro, I
in pain,
couldn't
dude. Then it's
breathe.
not even fun anymore.
yeah, I couldn't breathe when I was walking out of there, bro. I couldn't breathe. I was wheezing.
See, that's dangerous.
I was
dude.
wheezing on some real shit.
That's damn, dude.
Hey, but your boy turned 20 yesterday.
Oh, it was your birthday, dude. Congrats, dude.
Yeah.
Happy fucking birthday, Ramiro, dude. Did you get the choco flan? You get the choco flan?
Nah, I got a chocolate cake this time, but still.
Chocolate cake's good.
But next year, bro. Next year, you know, fucking finally finna be able to legally drink. No more illegally.
I know,
drinking,
right? No more illegal drinking. You can legally drink.
Yeah, no more illegal actions for this guy.
I think I started drinking less once I became 21. I was just like, oh well,
Right?
it's not fun anymore because it's legal. Yeah.
Right. I feel like it's that adrenaline rush,
You're like, I'm doing something bad. Oh, thanks for the post.
right? Because even smoking, bro, ain't all that anymore. Now that my parents know, like
Yeah.
it ain't all that no more.
I'm
Like,
glad you
I
think
still
smoking
smoke.
isn't all that. Yeah. All these things are all like not all. I mean, go have fun and whatnot, be responsible, but eventually you start realizing as you get
Yo.
older that I don't know, the health consequences keep adding up, and you can't
Oh,
like
no, yeah.
run, you can't think.
Yo.
You're like, shit, I should stop doing this.
Yo, that's a real shit. Them smoke lungs ain't no joke.
Dude, popcorn lung is real, dude. I tell all these kids that like
Yeah.
you know vape with that Chinese whatever juice stuff. I'm like, dude, like
Well, yeah,
popcorn
bro,
lung
like,
is
just
real,
look at
dude.
this-
You'll fuck yourself up.
Yeah, bro, look at this vape, bro. Like
What do you got?
shit,
You
look
got-
at this one.
Oh wow, it's orange. Wow, he's
You
blowing
see how
clouds,
it
dude.
broke that whole fuck-
It was.
Yeah,
It was a lot.
bro.
That's a lot, dude. Ramiro.
That's just a whole bunch of money. Like you see how fucked up I'm fucking up my lungs.
Yeah,
with
don't
this?
do that.
Kids,
Don't do it, Ramiro. Stop.
This. Kids, don't do
You gotta stop doing it, dude. You gotta stop doing it.
it.
All right, good. All right, I need to work on some questions with people, but it's so good to hear from you, Ramiro. I'm glad you're doing well and whatnot. Come on by the stream more often. We'll say hi.
Yes,
Okay.
sir. You know it.
All right, love you, dog. Enjoy. Happy birthday. Have the best time.
Appreciate it.
For sure. Okay. Nice. We got Poison Mouse. Is this Portuguese physics? This is what you need us to go through? Yeah? Here, let me start us up on YouTube too. Because now we're actually doing stuff. All right, let me start that up.
Now
it
you're
look-
teaching another languages too.
Another language, dude, right, Ramiro? You see this, dude? Yeah, I got people. It did look like Spanish at first, but also I know Spanish, and this is. It's like kind of in between Spanish and Italian, right? 'Cause,
Yeah,
like,
whenever they're speaking it, bro, you can kind of understand it. If you know Spanish, you can kind of understand it, but it gets to a point.
right. I definitely couldn't speak Portuguese, but I could like kind of understand Portuguese and be like, oh, okay, I get where it's going.
Yeah.
Because like qual, right? This is the same thing in Spanish, but I think you use a C instead of a Q, right? Is it like CULA?
Yeah. It's
Right.
like CUAL.
Exactly. Yeah. So in Italian, it would be with a Q. This is where it's interesting. Portuguese is this blend between I think Spanish and Italian. Because this would be qual S, right? Qual S, el vectore, or whatever the fuck. But in Italian, es is the same thing as e. So it's very interesting how it's in between Spanish and Italian to me. It's pretty cool.
By the way, Intero, you can't trash mice either.
You can't trash the mice. I don't know. Poison Mouse has a rat poison thing as his. I don't know what he means by that. Okay. But yeah, we'll be nice to the mice, Poison Mouse. That's your username. Let me see. Consider the system illustrated. The figure consisting of two conducting plates with area A separated by a small distance 2A and two different charge densities. Between the conducting plates are inserted two linear, whatever the fuck. All right, with different dielectrics. Epsilon 1, Epsilon 2. Cool, great. What is the electric displacement vector in the dielectrics? Oh, wow. Oh, this is this not J or something, right? Oh man, I'm trying to remember what this is. One sec. I need to refresh my brain on this part of physics. Epsilon? Yeah, no, epsilon is what we use for dielectrics.
Don't you have your doctorate in physics?
I do have my PhD in physics, but I don't know like all physics at all points in time. I have to sometimes go back and, remember things.
Of course.
I need to remember what like the electric displacement vector is. Is that just voltage? What the fuck is electric displacement vector? What? Well, voltage isn't a vector. Voltage is a scalar. Let me see. What do they call it again? D. That's right. Yeah. Oh, yeah. This is what I'm thinking about. Yeah. The D, dude. Yeah. D is equal to epsilon naught.
Said everything.
That's everything, dude. That's what it is. Epsilon naught E plus P. Dipole moments. Oh my god, no. No. I hate this stuff. It's like it has to do with like electrodynamics and electrostatics is very nice and easy until you start doing shit where you're not in vacuum or you're not in like a standard atmosphere or standard situation. Then you got to start adding in these other like terms, which is kind of annoying. So I think what I'm going to do is I'm going to use Gauss's law like regularly with what I would do without a dielectric, and then I think there's like an adaptation to it maybe. What's up, Nick? Good to see you. Or maybe, I think electric displacement is independent of epsilon. Yeah, okay. Because yeah, one sec. Let's go to. I think it's Gauss's laws. What classes do I? I teach everything, Brian, dude. I do a lot of physics, a lot of math. If you have a question in any of those things, you can submit a screenshot using the website down there. Right now, I'm doing an electromagnetism question for Poison Mouse here. Yeah. Okay. Here we go. This is what I'm thinking of. Okay, but this is for just standard electric fields. But what is it for? For fucking D. Here we go. Okay, here we go. Free charge per unit volume. Okay, cool. This is what we're talking about. Okay. All right, so Poison. Let's go over this a little bit. So, yeah. The electric displacement vector is basically electric field, but it also includes the dielectric. It is Gauss's law, correct? Yeah, exactly. We are going to use Gauss's law, but then we modify it a little bit because of this. Yeah. Or E dot ds. Yeah, that works as well. Yeah, for sure. So this is, from what I remember, you don't go over this in like a standard undergrad course, like intro undergrad, like year 1 physics. you do not deal with electric displacement. You deal primarily with electric field. This is a special case where we start dealing with what the electric field is within regions that are not vacuum or not constant. And in this case, you do have two different dielectrics. Okay, so we can still use this. Yeah, P is the polarization. Yeah, exactly. P is the dipole moment. Okay, so the key thing here is that div.d is equal to the free charge per unit volume. But let's think about like where there's free charge. Okay, charge only exists on this top plate and on this bottom plate. Within the dielectrics, there is no charge, right? So what we can say is that the free charge here is equal to 0, and then the free charge here is also equal to 0. Yes, right. Sigma. Yes, sigma is the charge. There is no charge within the dielectrics. Okay. So in that case, we don't have to worry about any charge contributions from the dielectrics, so it's not gonna mess up whatever, like Gauss's law. Gauss's law, we remember from standard E&M, is that right? E dot dA is equal to Q enclosed over epsilon naught, right? So let's see. Between the metal and the dielectric, okay. So between here and here, right? I see. Okay. Yes, you're all good, Sib. Appreciate it. Yeah, we'll go through it. I'm trying to make sure I'm completely coherent on this before I start. What's up, Emilio, too? Good to see you. Oh, let me get my TikTok chat working. One sec. I have to always, like, match the fucking thing. There you go. Cool. There we go. Okay, cool. What's up, Tyson? Okay. Integral form of, so for Gauss's law with dielectrics, you have this, right? Well, let's use the right color. So this dot V of D dot dA is equal to Q enclosed. Q enclosed, which is also like free. And notice how there's no epsilon naught here, right? Because that's that's kind of baked into this. Because D is equal to like E, epsilon naught E. So like that epsilon naught would just come underneath there anyways. Okay, cool. So if we were to do our Gaussian surface, right, which would be, you've done this before, Sib. Or wait, have you? Yes, you have, because you were in my summer class. I have to remember like which class you were in that I taught. If I make my pillbox like this, right? And let's say just at the border of this, okay? Then, okay, the area that's being enclosed, right? That's going to be equal to just like times A, right? So I can just say like D times whatever the area is. And then the charge that's being enclosed. Okay, so interesting here. The charge being enclosed, there is no free charge within this dielectric, okay? The only free charge that exists is from this bottom plate. So that's just going to be equal to sigma times A, right? And then the direction of that, right? Because DA is pointing in this direction, up, then D has to also point normal to that face. So the A's cancel. And I just get that D is equal to sigma, and then let's call this in like the n hat direction. So we're going to say that like this is n hat, for instance. Okay. Mm-hmm. Right, okay. So yeah, that's what it is. And then that's not going to change, right? Regardless of like where you are within the dielectrics, because there is no free charge anymore, right? Okay. So the electric displacement vector is always just going to be this. And that's going to be the same for whether you're in dielectric 1 or in dielectric 2. dA equals sigma A? Sure. So, charge enclosed is equal to, like... So here, if we want to talk about, like, sigma. So, sigma is equal to charge density, which is equal to charge per unit area, right? So, sigma is equal to Q... Sorry. Yeah. Sigma is equal to Q enclosed divided by the area. So then Q enclosed is equal to sigma times A. So that's where that comes from. And then dA, right? I mean, that's just the area at which we're looking here. Cool. Yeah? Does that make sense? Okay. Right. Okay. Cool. All right. B. What is the electric field vector in the conducting plates? Well, that should be 0. Right? Because you can't have... there is no, like, electric field within a conductor. I mean, that's just, like, known, right? What's up, Fembox? So, I feel like E should be 0. Inside the conducting plates. Oh, but in the dielectrics. Oh. Okay, this is where you have to start dealing with epsilon, though, right? Because the standard one, right, is that E dot dA is equal to Q enclosed over, like, I guess epsilon naught. So, so within the plates, in the plates, E is equal to 0. Now, let's talk about in the dielectrics, though. Dielectrics, right? Dielectrics, yeah. That's a little bit different, right? So, we know from here that D is equal to... I think this is just epsilon, I don't think it's epsilon naught. I think it's epsilon naught if it's in vacuum. D is equal to epsilon E. Okay. So, oh, and they give us what they are, right? Okay, cool. So then D1 equals epsilon 1 E, which is also the same thing as D2, which equals epsilon 2 E. So this is going to tell me actually that the electric fields are different. So while the electric displacement vector is the same for epsilon 1 and epsilon 2, the electric fields are going to be different. So we showed earlier, right, that because there's no free charge enclosed, I don't care about the polarization right now, that D is always just equal to this. D is equal to sigma n hat. So I'm going to have that sigma, which is in the n hat direction. All right, sigma n hat is equal to epsilon 1 E1. So that means that E1 is equal to sigma over epsilon 1 n hat. And then that E2 is equal to sigma over epsilon 2 n hat. And then I think they gave values for this. Yeah, epsilon 2 is equal to 3, epsilon 1 is equal to 2. Okay, sure. So that's equal to sigma over 2 n hat. And then E2 is equal to sigma over 3 n hat. Cool. Does that make sense, Poison, for getting the electric field vector? And then I see how we're going to get this eventually to get the polarization vector. Oh man, and then they want us to do capacitance. This is a mess of a question. There's a lot going on here, dog. Also, let me make sure my YouTube is streaming correctly. Sometimes it fucks up. Oh, it says we're live. That's great. Cool. Where's my chat? YouTube's fine. Cool. It says my YouTube is fine. I'm glad my YouTube is fine. I don't know why I can't see my chat for it though. What the hell? Oh, there it is. There. Okay, now I can see it. Yeah, okay, cool. Okay, cool. That makes sense. Awesome. All right, so now let's get to the next part. Which has to do with the polarization vector. Your bot made a stupid correction. You know what? 9 times out of 10 it's correct, though. But every once in a while, yeah, it doesn't get the your right. But I'd say it gets it right more often than it gets it wrong. Okay, so from before, right, we know that D is equal to epsilon naught E plus P. And then if we want to talk about polarization, where does that come from? I'm gonna go find that. Polarization vector. Where is it? Oh, okay, cool. This is what I want. Bingo. This. Okay. P is equal to that. What the fuck is chi? Chi is a tensor. I don't want to deal with tensors. What? What? Excuse me? Do I need to deal with tensors here? I don't think I need to. Why do they make life so hard? What's up, Jovial? Oh. Electric susceptibility. Relative permittivity ER is by this. In this case, oh, in vacuum. Oh, okay. I think I get this. Let me try to man. What level of E&M is this, Poison Mouse? This to me strikes me as upper div or like grad level. Starts getting into like all the nitpicky shit. It's undergraduate? That's a little advanced for undergraduate, I would say. I didn't teach this in my undergraduate class. Okay, so XE is equal to 0. Oh, when... oh, okay, and I think epsilon R is equal to like epsilon over epsilon naught. Is that correct? I think that's correct. I think this is relative permittivity is what this is. So you're relating the permittivity of your whatever your material to like the permittivity of free space, which is vacuum. We love vacuum. Vacuum's so nice, especially if it's a Dyson. Okay, so wait, let me derive this. So chi e is equal to epsilon over epsilon naught minus 1. But I have epsilon naught chi e. Oh, okay, watch what happens. Let's multiply both sides by epsilon naught. The math might do some cool shit here. Right? Yeah, okay, watch. This will cancel, right? So this is equal to epsilon minus epsilon naught. Aha. Okay. So I think I can rewrite this. Let's rewrite this as P with this. I mean, this is the vector we're looking for, right? The polarization vector is equal to chi epsilon naught is the same thing as epsilon minus epsilon naught. Okay, epsilon minus epsilon naught, and then that's times E. Okay. And then from before, we know that D is always equal to sigma n hat. And then we have results for E1 and E2. Okay, I think I see where this is going to happen. So, okay. Sigma n hat, well, fuck the vectors, whatever. We all know it's pointing in the n hat direction. Is equal to, so that's going to be epsilon naught. And then let's do the first interface. Let's do E1. And so that's going to be sigma over 2. So that's this part. So it's this times this. And then plus the polarization vector. So plus P. Which, interesting. I wonder if this works out. This is physics. This is pretty big physics. Okay. Oh, so I can just figure out what this is, right? So does that tell me right away that Oh, wait. This is 2, but I think this is 2 epsilon naught. And this is 3 epsilon naught, right? When they just said that, okay, well, bro, what? They say epsilon 1 is equal to 2. I think what they're saying is that epsilon 1 over epsilon naught is equal to 2. So epsilon naught is equal to 2 epsilon 1 is equal to 2 epsilon naught. I'm not saying a number, bro. I'm cooked. No. This is upper division E&M. Don't worry. I will do some simpler math questions in the future. If you want to submit a question for us to go through, please do so. There's a website right down there. If you have like a screenshot of something you want to go through. This is more advanced E&M is what this is. I know. You're like, where are the numbers? I need my numbers. Where are all these fucking letters? Okay. This is how this works out. It's not in the question. Yeah, I agree it's not. Well, they're kind of like fuck bags for not putting that in there. Okay. When they say like, right, they say epsilon 1 is equal to 2. They're saying epsilon 1 over epsilon naught is equal to 2. I think they're talking about like the relative permittivity. What does epsilon represent? That's a good question. So epsilon represents how it's a property of the material into how electricity moves within it when you have like electric fields applied and stuff. When Dr. Gold is doing non-math, it's a good time to get snacks, beverages, use the restroom. Fuck. Okay, here.
Fuck.
Dude, seriously. This question, man. Exactly, dude. Okay, I think I got this. I got this, boys. Watch. Okay, I'm gonna cook. I'm gonna cook real quick here. And then this is plus P. Okay, cool. Watch. This bitch cancels, right? Okay. And so this tells me that, and here, we're gonna do this for P1. So this is sigma minus a half sigma is equal to P1. So then P1 vector is equal to sigma over 2 n hat. Cool? Do we agree with that so far? So let me like recap what the hell just happened here. Okay. So we used this property, right? I'm just gonna solve for P. So I'm gonna move this over. And that's gonna tell me that D, the electric displacement vector, minus epsilon naught E is equal to P. Sebas says, I'm watching this while studying AP Physics. Of course there's no numbers. It's college math science. Yeah, it is. Well, welcome to the hard mode of life. It sucks sometimes.
What the fuck is this piece of shit?
Yeah. Okay, so watch. This tells me that P1, right, is equal to D, which is this D1, which is technically the same everywhere, right? Minus epsilon naught E1, okay? So that was equal to sigma, because that's always D. And then this was epsilon naught, and then this was going to be sigma over 2 epsilon naught. By the same token, P2 is going to be equal to D2 minus epsilon naught E2. Okay? Which D2 is the same as D1. It's just sigma. But now this is going to be epsilon naught, and then this is going to be sigma over 3 epsilon naught. Okay? So, your answers are going to be that P1 is equal to sigma over 2 n hat, and then that P2 is equal to 1 minus a third is 2/3, so you get 2/3 sigma n hat. Okay? So I think that's almost, we're almost done. We're almost done with the Painland, guys, don't worry. We're going to be leaving Painland soon here. Determine the capacitance. Oh, okay. So capacitance, I know from being a 90s kid, or I was really like, yeah, I was a kid in the 90s. I was born in the 90s. Yeah, fuck it. There used to be this TV show where they sold shit. It was called QVC. And so I always remember this, like Q is equal to V times C. So the charge on a capacitor is equal to the voltage difference between the plates times the capacitance. And so we can rearrange that, right? To say that capacitance is equal to the charge divided by the voltage. Now, this might get weird with dielectrics that aren't uniform. Because I think in here they said, like, imagine it's two capacitors in series. Yeah. So how they're thinking about this situation here. So you have a plate with charge, a plate with charge. You're thinking of it like this. You think you have like minus this, and then you have this, and then this is plus, right? And so I believe this represents epsilon 1, this represents epsilon 2. And then this is like the interface between the two. And then we have to... So I think what we're going to do is we're going to find the capacitance of one of these. Then we're going to find the capacitance of the other one. And then we're going to add them. And then capacitors in series add like resistors in parallel. Ooh, Winning Leap says, can you make videos solving kinematic questions with multiple moving objects? I have done those before. Are you talking about like collisions? Like inelastic versus elastic collisions? I actually do need to do a video on collisions. I've done it on like momentum. I think I've done stuff on momentum. But yeah, I will be getting into more like making video stuff probably the next couple weeks. Okay. So, Dude, Coriolis Force, stop. Oh, man. What's up, Mad Programmer? Okay, let me look up some stuff. I need to look some stuff up. Well, can I just do the difference in the electric fields? Let me see. Capacitance. Yeah, I think I just need to figure out what the potential drop is. Is there enough polarization already? Yeah, dude. There definitely is. Okay, here we go. This is kind of what I want to talk about. Yeah, because what happens is, like, the dielectric has its own, like, opposing electric field that, yeah, E-polarization, and this, like, messes with what the effective electric field is, which then would mess with figuring out what the potential drop is, right? Okay, so from this equation here, right, I already know what Q is, right? Q is just sigma or whatever. Sigma A, right? But then I need to figure out the potential drop, okay? So let's figure out what the total potential... I know we could do it as 2 in series, but I feel like if I just figure out the potential drop from here to here, then we'll be good, right? So let's do that. So over V. All right, so let's figure out V. So we know from Gauss's law, right? V is equal to the integral of E dot dl. Which means if the electric field is constant, but within like 2 different regions, that's going to be E times D1. So E1 D1 plus E2 D2. Right? So as we cross, let's call this like D1. Let's call this D2. And I think we said that the distances were equal. Did we not? I think we did, right? Yes, good. Separated by a very small distance, 2A. Each with area A. But, well, yeah, each of thickness A. Okay, great. Okay, cool. Yeah, 2A, right? Okay, cool. So this is A and this is A, right? Whatever. This is A. This is A. Okay. So that's going to be equal to E1A plus E2A. Okay. E1 we already figured out, right? What was E1? E1 was sigma over 2 epsilon naught. And that's times A. And then this is plus sigma over sigma over 3 epsilon naught. Yeah. Times little a. Okay. I got you. Internal, you're good. Okay. And then that's sigma times A. Okay, okay. Oh, okay, okay, okay. Yeah, no, I think this is fine. So a half plus a third, right? Let's see if I remember how to do a half plus a third. So that's 3/6 plus 2/6. So it's 5/6, right? Yeah, cool. So I get 5/6 sigma A over epsilon naught. Yeah, I will definitely do more after this, Sebas. If you want to submit a... Did you submit one to our web help screenshots? Sibley put one in. Me put one... Well, me submitted it like 3 times. Yeah, exactly, yeah. Yeah, if you submit a question... So here, on our... This is where people like submit screenshot questions. If you do it on that website that I have down there below, submit.actual... Okay, you're doing it right now? Okay, cool. I'll see it. Okay. All right, cool. This is equal to V, right? So then C is equal to sigma A. So big A over 5/6 sigma A over epsilon naught, right? So then I think we just I think we just rearrange this, no? Oh, the sigma cancels. Nice. Okay. So that's gonna be 6A epsilon naught all over 5. Yeah? I think so. Yeah. Cool. Alright, I think that's good for that. We don't know what A is. Yeah. Oh, it says with area A. Okay, cool. Oh, we're fine. We're fine then. Okay, cool. That's awesome. Determine the energy change when the dielectric sheets are removed. Okay. So that's just comparing 1/2 CV squared to 1/2 CV squared, right? So energy of a capacitor is equal to 1/2 CV squared. So if this was just a normal ass capacitor, right? What's up, Bobby? I think it's just... Yeah, it's just sigma over epsilon. Okay, okay. So for a normal capacitor, so for normal capacitor, right? V is just equal to E times the distance, right? So that's going to be E times 2A, and then the electric field of a normal capacitor is just, I think it's just sigma over epsilon naught, right? So you have sigma over epsilon naught times 2A. And then you appreciate, thank you, dude. The JEE exam, dude, that exam sucks. Okay, and I think there's an even easier way to do this with just in terms of V, right? So if Q equals V times C, then C is equal to Q over V, right? So I could rearrange this as saying, oh, this is 1/2. Or actually, I could rearrange the V. Let's just rearrange the V. So V is equal to Q over C. So then V squared is equal to Q squared over C squared. So you get 1/2 C Q squared over C squared. So it's just equal to 1/2 C, 1/2 Q squared over C. Okay. So for a normal capacitor, that's equal to 1/2 sigma squared A squared. That's Q. Divided by the capacitance. And I believe the capacitance would just be, I think it's going to be 2A sigma over epsilon naught. Two big A, sorry. Wait, no. Yes. 2 big A epsilon naught. There is no sigma. Okay, and then for the dielectric capacitor, you have, that's equal to 1/2 same charge, sigma squared, but now dividing by C. C is now this, so you're going to have 5 over 6 A epsilon naught. Oh, and there's still an A squared here. Okay, cool. So then what's the difference between these two things? So let's pull some stuff out, right? So I can pull out 1/2 sigma squared A squared. Well, actually, one of these A's will cancel, right?
Nice.
Yeah, I'm going to divide the A's. Yep. So 1/2 sigma A. And then we're going to have, so that's 1/2. Oh, and let me pull the epsilon naughts out, right? So that's just 1/2 minus 5/6. So wait. Okay, so when they're removed. Right, so final minus initial. So yeah, you should be dropping energy, right? Yeah. You have more energy when you have a dielectric in there. Chug. Thank you, book buyer. I do need a chug, thanks. Okay. So 3/6 minus 5/6 is 2/6. So 1/3 times 1/2. Okay, so the delta is equal to 1/6 sigma squared A over epsilon naught. I think that's what it is. Oh yeah, you are right. Yeah, why did that stop? That should have. Oh, you know why? Sorry, because Twitch does this whack thing where the connection resets every once in a while. One sec. Let me reconnect it to Twitch. Yes, get all my stuff. You can access all my Twitch stuff. Thank you. Okay, it should be working now. Your brain hurts? Mine does too, honestly. It's all good. Okay. How long do I typically stream for? About 2 hours. we're done with this question. So Sebas, I can work on yours now if you want. There is a negative sign jokes. Correct. Correct. Thank you. Thank you for catching that. Yeah. You have a drop in energy when you remove the dielectrics. I mean, the other way to see that, right, is capacitance, right, is equal to epsilon naught A over D. Is the hat with headphones on top? What do you mean? You talking about this? You talking about my headphones? Right. So here you go. Yeah. So capacitance is increased when you put a dielectric on there. Oh, my head hurts. Oh yeah. Okay, so that's why this is negative, because once you pull the dielectric out, you drop the capacitance, and energy of a capacitor is related to CV squared. So yeah, that's why that happens. Cool. Does that make a little bit more sense to you, Poison Mouse? This was a really fun, long, drawn-out question, but I enjoyed it. It was a good foray into... Dude, I fucking hate dielectrics, by the way. You will review it? Cool. Here, what I'm going to do for you, Poisoned, I'm going to save all this as a PNG so that you can go back through it later. So I'm going to say this is Poison dielectric. Yes, I got you, bro. There you go. Here, I'm going to drop in the chat here so you can see it. Yeah. Oh, I might have made a mistake here. Wait. We didn't include... We forgot the A here. Wait, what? There should have been an A here as well. My bad. Sorry, there should have been an A here. Fuck. So this is A. Oh, and then this I think would be... Boom. This would then be 2A, I think. One minus 5. Oh, that doesn't make no sense. No, it has to go down. Oh, wait 1 sec. One fourth. 3. Yes. Okay. Sorry, this has to be a fourth. Let me fix it. 1 sec. Yeah. The reason for this is oh, I already put the 2A in there. Oh, wait. E is, yeah, sigma over epsilon naught. Wait, we did the Q squared over C. Right. And then for a regular capacitor, C is equal to sigma A. And then, yeah, but the V is not just epsilon naught. Q over V. I think there's like a 2 epsilon naught here. Which maybe I included. Or... I forget. There's maybe a factor or 2 off somewhere. Just check it. I don't know. I've been working on that question for like 30 minutes, so I'm done. But you're welcome, yeah. Take a look at it. Do I stream every day? I stream Monday, Tuesday, Wednesday. So if you ever want to know when I stream, yeah, recheck it, watch the video. Yeah, please. Here's our live stream schedule. I'll paste it into all the chats for you guys. So there's our schedule. So you can see our next stream is going to be tomorrow, starting an hour later. So that's at 4 o'clock Pacific. This red line will show like what your current time zone is. Yeah, get the mouse, go to bed. All good. And then also stream on Wednesday. I'm debating also streaming on Thursdays and Fridays. But for now, it's just Monday, Tuesday, Wednesday. But yeah, around this time. Monday, Tuesday, Wednesday. Good night. Yes, you're good. Okay, awesome. Let me see this one real quick. This is from Sebas. This is a standard physics question. You can ask whatever questions you want, by the way. So, like, I tutor everything from, like, chemistry to statistics to... I mean, my PhD's in physics, but I do a lot of math as well. Jeff's waiting for me to do some more math. He's, like, a little annoyed at the physics right now. Okay, here we go. 55-kilogram person stands on a scale on the moon. On the moon, G is equal to this. What is the force from the scale on the person? Cool, that's the normal force. Very cool. So, okay. So you have person. Okay. And they have 55 kilograms. Okay. So, they are going to exert a force downwards due to, we're going to say gravity. And that's equal to mg. Which in this case, if we're on the moon, G is 1.6. So that's going to be 55 times 1.6. Now, in order for the person to not fall, like, through the scale needs to also exert a force back up on the person. Okay? And so that's the force. We call this the normal force because it's the force normal to the surface. Exactly. Yes, Odin, I'll do yours next. Yours is math. Okay. And we know that this normal force must equal this force because the total force is on the person, so the sum of the forces, which is equal to F, I would say like Fn minus Fg, must be equal to 0, right? If this person is staying still. I realize they don't have any legs. Let me fix that. Sorry. There you go. Now they have legs. Very short torso. Okay. So this tells me right away that Fn is equal to Fg. And Fn is the force of the scale acting upon the person. Down is negative, correct. Yep, I'm calling down negative. That's why this Fg term got the negative here. So, yeah, pretty easy here. So, Fg is equal to 55 times 1.6, which... Where's my calculator? I should be able to just do this in my head, but... My head is a little wrapped after doing all that dielectric stuff. Yeah, okay. So if we look at the calculator. And we do 55 times 1.6. Cool. You get 88. Nice. Okay, so yeah. So the force of gravity is 88 newtons, which also means that's equal to the normal force. And so that is the force of the scale on the person. That is 88 newtons. Cool. Oh, it does say the answer. I didn't even fucking notice that. Sorry. Yeah, it's right there. Four different things? Yeah, no, you don't need to do that. Now, I mean, a cool thing to do here is what I call like a parent weight. Because, again, no one really describes things in terms of newtons, you know? I don't go to my friends and be like, yo, bro, you know, I just lifted, like, 400 newtons. They're like, I don't know what the fuck that is. 400, like, what? We tend to put things into units that make sense to us, which I know that kilograms is technically a unit of mass, blah, 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 but whatever. A parent weight is, like, how many kilograms would that force be equal to on Earth, is what I like to think about. Or, like that mass on Earth would how much mass do I need there to also equal the same? So on Earth, right, I have some m times g also equaling to 88 newtons. And I want to know, like, how many kilograms on Earth would that be? So the easy way to do this with a parent weight is you take whatever your number is and you just divide it by g. So m is equal to 88 over 9.8. I know this is technically a mass, but I don't know. This is like, yeah, murder me if I'm gonna like be saying the exact wrong terms or something. Or don't murder me, please. There's too much of that happening these days in the world. 88 divided by 9.8 is 8.97. So around 9 kilograms. So here's the cool thing, right? Is that this 55 kilograms on the moon weighs the same as 9 kilograms on Earth. 88 newtons is like a kilogram's force. Yeah. Yeah. And this is why you weigh lighter on the moon, or you have an apparent like lower mass. Yeah. Cool. Okay. Glad that made sense to you, Sebas. Congratulations. Good job. Okay.
Well done.
Sebas says, my teacher is not good at teaching it in a way that I can understand. I know. I get that, bro. Teachers can only really teach one way because they have to teach to like so many people at once. So they try to usually pick like some middle, like down the middle of the road, you know, way that will make sense hopefully for the most people in your class. Because individualized education, like what's happening right now, where like I'm explaining to you like as an individual, it's just too expensive for like schools to do that. So that's why we're here. So yeah, if your teacher's not making sense, come here and I'm happy to like figure out a way that makes sense for you so that you can understand. Wow, Obi's rating. What's up, Obi, dude? Thank you, Obi, dude. My man. Whoop, whoop. Yeah, someone says, do I do YouTube full time? No, not yet. I would love to do this full time, but currently this does not pay my rent. So I do many other things to be able to exist in this expensive world. If I kept doing this full time, that'd be great. I'd love to do that. How is everyone tonight? I'm doing great, Obi. Start of a week. I fixed my generators today. I'm so happy. I'm going to show you. I have some pictures of this fucking generator, dude. I could not get my generator to start. I took these to Burning Man, and Burning Man unfortunately like eats electronics. Does this video want to load? Come on, dog. We can get it a load. Sometimes don't want to load for me. Come on. Okay, well. Oh, there we go. There we go. So this is me like trying to like get my generator to start. It just won't start. I'm like, damn it. This is like portable electricity. We bring these out to the desert and stuff. So I ended up taking a lot of tools to it. Yeah, 7,300 on YouTube. Yeah, we're doing good. So I had to like get all the fucking dust off of this thing because there's a lot of dust in the desert. But that still wasn't starting it. So what do we have to do next? Okay, why is this audio still playing? Stop. Oh ho. Yes, this is what happened. So, let me mute this. Turns out the spark plugs were bad. So this right here is a spark plug on the left, which is probably not going to do very well in any sort of engine. And then this is a new spark plug here on the right. So, put the new spark plug in. And I think she started. Do I got a video of she starting? Yeah, this is her. She did start. Wants to load. Google needs to like fix their algorithm with like loading videos, dude. Okay, here we go. So yeah, look. First try. I pray. I pray. Did she start? I forget. Yes! Look at that. Anyways, so yeah, that's how my day went today. I was diagnosing this generator, why it wouldn't start. Turned out the spark plugs were bad. So yeah. Bobby says, I'm going to study friction today, so tomorrow I'll ask you JEEs. Oh no. I mean, you can ask me JEEs, but those tend to like make me upset. But I'll try them for you. Nice. Congrats, Archaeological, for getting into... Is that National Institute of Technology? Warangal? For a degree in engineering. Really cool, man. Okay, let's see. This one is from Odin Root. Holy deltoids. I do work on my delts. It's his dream college. Sweet. Well, there you go. Someone here on my YouTube goes to your dream college. So you can too. You're at least both in the same place, right? Like great minds think alike or something. Let me get the calculator off my screen, sorry. My bad. Okay, here we go. Find the equation of the plane that contains the two parallel lines. Okay, so we have 1 plus 2t minus t minus 1 plus t. Okay, I'm going to break this up into like parametric form. So this is the same thing as 1 comma 0 comma minus 1 plus 2 comma negative 1 comma 1 t. Yeah, so it's like the starting point, and then this is like the slope term, kind of. Yeah. Right? I think we're good with that, yeah? So then the other one, so this is like line 1. Line 2 is going to start at 0, comma 1, comma 2, plus, and then that's going to be minus 4, comma 2, comma minus 2, comma t. I could also find 3 points, and that would define the plane. That is another way to do it. You're not wrong. I was going to just, like, cross-product these two vectors. Right? And then get a normal vector, and then just, yeah, use a point on the plane to do it. I think that's the same thing, Jeff, though, right? Because with the 3 points, I would still need to get two vectors and then cross-product them anyways. Yeah? Is there another way to get the equation of a plane from 3 points without doing cross-products? I'm not sure. Oh, you could just solve by ax plus by plus cz equals 1? Wait, why do they equal 1, though? You mean equal 0, no? Wait, is that the form of a plane? It has to equal 1? Why the equals 1? Boom, 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 boom. Because then things can have offsets and stuff. But plus 1 is just any number you can divide both sides unless the plane passes through the origin. Yeah, then you're fucked. Yeah, so let's not wish that upon ourselves. Okay, I'm gonna do it this way, which Odin, these are two vectors, which if I know those vectors are in my plane, then the cross product of those two vectors will get me the normal vector to the plane. Right? If I have this, and then I cross them, I end up getting this, which is the normal vector to the plane. So let's just cross them. See what we get. You can just smell test the origin. Wait, that sounds wrong. It's my no-no square. Swipe or no swiping. Okay, IJK. I'm just kidding. So let's do the cross product. So this is like V1 cross V2, which should get us the normal vector, right? So to do a cross product, if you guys remember, very important thing to know how to do. I do like the T method, so I do this, and then I do this. So the determinant of this is -1 times -2, which is 2, and then 2 minus 2 is 0.
Oh, yeah.
Fuck yeah, dude. What? Oh, that's nice. Okay, so 0 I hat. Duh. Let me get this one. So then that's -4. -4 plus 4, which is also 0? Uh-oh. Wait a minute. Oh, wait. These lines are parallel. Of course the cross product's gonna be 0. Oh, that's annoying. Yeah, so sorry, this isn't gonna work. Yeah, duh. Okay. I totally forgot that these were parallel lines. So, yeah, if you have two parallel lines in the plane, you can't cross them. I was like, wait, why are they both all coming out to be 0? That was really dumb, wasn't it? Damn it, I need the 3 points after all.
Surprise, motherfucker.
God damn it. Fuck. Okay, fine. All right, let's get 3 points. Let's make Jeff happy. Let's get 3 points. I should have known that. Yeah, two parallel lines. Yeah, you can't cross product them. Is there a generalization for n dimensions? Would be getting the subspace work? That's a good question, Lynn. I believe so, because you can do cross products in like infinite dimensions. I think you just need points, right? And then cross them. Now, I am curious. Yeah, no, because the generalized form, right, for a plane, I want to say it's n dot r minus r naught is equal to 0, right? Lynn says cross product is defined for 3 and 7, isn't it? Oh, interesting. Is that true? Jeff seems to think that if you have 3 points, you can just do this. You can just do ax plus by plus cz is equal to 1. So then if you add more dimensions, then it becomes like plus, I don't know, like d whatever your new coordinate is. I'm unsure if this is a totally correct way to do it, but we're going to do it both ways. I'm going to do it with the cross product method, see what I get, and then I'm going to do Jeff's way of like creating like a 3x4 matrix. And we'll see what we get. I think that should be cool too, right? Yeah, a plane is just a subspace, yeah, right? I think it's one smaller than the dimension you're in, right? Right, so if you're in 3D space, a plane is defined as a 2-dimensional object. It's like the shadow. Yeah, right? Yeah, it's taking it down a dimension. Pranov says, bro, tell me a book for maths, like advanced maths for probability and calculus. I can give you a calculus textbook if you want one. Or you could go start learning like differential equations. That's more advanced. Or vector calculus. Poipoli says, what's up, dude? I just started to geometry train and trig train. Hope to be able to finish math. Nice, dude. Sebastian says Stewart's calculus is great. Okay, I don't think I've used Stewart. Sounds like a cool guy, though. This guy looks smart. Who's this? Who are we going to watch? Oh, this is the... Yeah, go sound in it with this girl, too. Okay, here we go. Oh, I see. The equation of a plane is... Yeah, ax plus by plus cz... Oh, plus d is equal to 0. I see. And then you could just divide by whatever to get d is equal to 1. Feels... Okay, cool. Poipoli says, I took an entire calculus book from the library. It was huge. Why is it huge? Because there's a lot of topics. So, for instance, I love this book. I have it on my Dropbox. If you want it, just DM me. I'll send you the link for it. I like Rogowski. I think he's a great guy. But, yeah, his book is just called, like, Calculus. If we look at the amount of chapters in this, it's actually quite nuts. So, I mean, chapter 1 is, like, a little pre-calc review, but then he goes all the way up to, like, chapter 18. Like, he stops at Green's theorems and Stokes' theorem. This is, like, multivariable calculus is what it is. And, look, this is page, like, 1,000. But it is useful stuff. This is all technically calculus. It's vector calculus, really. It's like multivariable calculus is what we call it. But, yeah. Okay, let's get our 3 points. I'm going to get 3 points. So I'm going to do L1 at 0. I'm going to say t equals 0. So let's see what that gets us. So that would be 1, 0, minus 1. I can do L2 at 0. That's going to be 0, 1, 2. It's college level, but in high school, if you're taking AP calculus, it's the same. And then let's just do, let's do L1 at 1. So that would be equal to 3, minus 1, 0. Okay, cool. We got 3 points. Yeah? So I just plugged t was equal to 0 for this, t was equal to 0 this, and I plugged t was equal to 1. I think it was okay. You're destined to learn math forever? Yeah. No, dude, math never ends. Yeah, you just always need math. You always need math. It's forever, dude. Okay, so let's get some vectors. So I'm going to call like v1 is going to be equal to like L2 minus L1. So that's going to be -1, comma 1, comma 3. I'm going to get v2. Well, L2 of 1 minus L1 of 0 is equal to L2 of 1 minus L1 of 1. Or L2 of 0, sorry. Sure. Oh, you're right. You're totally right. Because this connects the two lines. So you're right, Jeff. I could just pull the other vector because it can't be parallel, but it's okay. I'm just going to do it anyways. So we don't really need 3 points. We needed 2 points. We just need a point on each side of the line. Gibberish? Here's what we're doing. Here, you want to see? Popoil, I'll get you up to speed. We have a plane that has 2 parallel lines, which are parametric, because the lines depend on t. So there's some initial starting point, and then kind of like a slope that varies as you increase t for 2 different lines. And I'm trying to find the equation of the plane that contains these 2 lines. So what I'm doing is I'm finding, let's say this is like L1, and let's say this is like L2. I'm finding like a point here at t equals 0. I'm finding a point here at t equals 0. And then I'm finding another point here at like t equals 1. Oh, you just started playing. Oh, cool. Then this is going to be so relevant to you right now, dog. So what I did was I then found what this vector was. This is v1. And then I'm going to find out what like this vector is, which is going to be v2. Yeah, this is v2. And once we have these 2 vectors, vectors are things that connect points. They're like lines in 3 dimensions. The simple way for me to explain it. Okay, so L2, so 0 minus 3, so that's -3. 1 minus -1 is 2. 2 minus 0 is 2. Cool. Now I can take the cross product of v1 and v2. Cross product will get me the perpendicular vector to these 2 vectors. So it's like the thing that's 90 degrees to both of them. So again, I, j, k. -1, 1, 3. -3, 2. 2. Let's do the method. Love the method. The T method. Okay. So that's going to be 2 minus 6. So that's going to be -4 I hat. And then that's going to be -2 plus 9. So it's going to be 7, but then there's another minus. So that's -7 j hat. And then this is going to be -2 plus 4, which is going to be 2. Let me see. Popoli says, how you got 3 numbers and z of vector if vector 3D... If my grammar sucks, it's okay, dude. To v1 and v2. Yeah, so v1... So... It's just finding, like, what is the slope between, like, 2 points. We're just subtracting all the coordinates of L2 at... sorry, this is at 0. At t equals 0, which was this, minus the point on L1 at t is equal to 0. T is like a time thing. Like, imagine something is, like, on this path, but at different time points. Like, that's what t is. We had to find them. We found them using this. They gave us the equations of the two lines. And so from these equations of the lines, I kind of split it up into what's like slope-intercept. Which this is kind of like the slope, and this is not really the intercept, but it's like the starting point. I mean, but that's what like slope-intercept is in regular lines, right? The intercept is like where it starts on the y-axis. Anyways, okay. So this is the normal vector. We don't have an L3. There's only two lines. So this is the normal vector. So then the equation of a plane is defined as... So if k-hat's wrong, thanks. All right, let me see. Y. -2... Oh, -2 plus... I don't know why the fuck I put it +4, dude. I added these two numbers together. Oopsies. Thank you. Thank you for catching that. Jokes. -2 plus 3 is just 1. Thank you. So n is like... It's like some like A, B, C, basically. And then we have to have like an x... like... We have to have a point. So then you have like some point on it, which would be like x naught, y naught, z naught. And then I believe what the formula is it's a x minus x naught plus b y minus y naught plus c z minus z naught is equal to 0. This is called a cross product. And the reason why we do that, Popoili, is if I have two vectors, v1 and v2, the cross product of these two gets me this, which is a vector that is perpendicular to v1 and it's also perpendicular to v2. That's called the normal vector. When finding the equation of a plane, this is what the definition is. So it's the normal vector, which is ABC, and then x minus x naught, y minus y naught, z minus z naught, where x naught, y naught, z naught are a point on the plane. There's a very cool diagram I'll show later for like where the fuck this comes from. It turns out, I think it's this dot, and then I think it's r minus r naught is equal to 0. I think this is how this works. I'll show a picture for this later for where this comes from. Just keep that in the back of our mind. Okay, so let's do this. So in this case, a was -4. So -4 x minus, and here, let's just get a point. I like this point, 0, 1, 2. Let's just do it. 0, 1, 2. That works. So x minus 0 plus b. B is -7. So we're going to say -7. Y minus 1. Plus 1 for c. So I can just leave that. And then that's going to be z minus 2. And let's see what we got. So I got -4x. Just had your physics class? Cool. How was your physics class today? Plus 7 plus z minus 2. This is why I do this for my z's, because my 2's look like z's. Okay, so then we get -4x minus 7y plus z minus 5 is equal to 0. Or I say like is equal to 5. Nick says, don't forget about me. Okay, I'll do yours next, Nick, if you want. I don't think anyone else has submitted a question. Yeah, okay. I think this is correct. Why 3 hidden numbers? What numbers are hidden? There's no... What are the... Are you talking about this stuff? Well, that's me showing how to do a cross product. All right, let's throw this shit at ChatGPT. I always like to see what ChatGPT says. Here we go. Solve it, chat. Why the 3 hidden numbers? I don't know what the 3 hidden numbers are. ChatGPT is always wrong? I mean, let's see. It's going. It's doing what I think it should be doing. Cross products. Plane equation from parallel lines. I mean, these are true things. Here we go. Cool. Blah, 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 blah. 4x plus 7y. I just do it for my own sanity, just to see if it's the right answer. Sorry. So let's see. ChatGPT got this, which, yes, if I multiply everything here... Oh, fuck. Sorry, this should have been minus 5. Right, because it's 7, minus 2 is 5, then you move it over, it's minus 5. Aha, see? ChatGPT does help me find errors. If I multiply this all by -1, then you get this. Nice. Love it. Cool question, Odin Root. Wait, who are you in my fuck, what's your name in my Discord again? So I can give you points. I'm trying to give you points for things. I will show the diagram. Funny Snake. Okay, here, I'm gonna give you a nickname in my Discord so that I know that. One sec. I can do this. I can view full profile. I think I can give you nicknames. Can I not give you nicknames? The hell? I'm admin, dog. What do you mean? I gotta open you up in mod view. I thought I could nickname people in my Discord. Did they get rid of that? Nickname him Da Plane. Whatever, I'll deal with it later. Sebas says, that's a smart way to use AI. Most people in my class use it to do assignments and then never learn anything. Yeah, exactly. Don't do that. AI is a great tool to, like, check yourself. And again, like, I found I made a mistake. I forgot, like, a minus sign. I'm like, cool. AI helps me, like, figure that out. If you're using AI just to get your assignments done, you're not learning shit. I say it's the same thing if you go to the gym and you brought a forklift with you. And you were just like, here, I'm going to have the forklift to, like, lift all the weights. Like, cool. But you're still going to be, like, really weak because you're not building any strength. Because you're just using a forklift to lift things. I think that's like my number one thing I try to get across to students when they say, like, why am I doing this? Why am I learning this? Like, when am I going to use this? I'm like, you might never use this, but the process of learning it, mastering it, builds so many, like, other skills that you will use to figure out other shit that you actually care about. Yeah, gym with a forklift, right? Wild.
Oh, yeah.
I want to see real quick if well, here, let me show the diagram. Real quick. Math notes, equation of plane. It's from this. He does it oh, here it is. This is it. Yeah, I love this picture. It's actually a really good picture. Okay. So this is kind of the diagram we like to use. Okay. So in this case, R points to points somewhere on the plane. So we say R points to somewhere somewhere on the plane. So much geometry in the question. I want to puke. It's okay. I like geometry. It's like the ugly stepsister of math. How the fuck are paper planes inside a plane? Okay, so R vector points to somewhere, anywhere on the plane, okay? Which, that's always going to be some coordinate x, comma, y, comma, z, right? Do we agree with that? Usually, like, you give an x, y, and z, that's somewhere on the plane, okay? R naught points to a, like, known value on the plane. Okay, like somewhere you know for sure. Like, that is a point on the plane. if you were to do r vector minus r naught vector, you would get a vector that connects the 2 points, okay? And that's what this is. This connects, we would say like x comma y comma z to, and here, I'm going to say here, right? So a known value on the plane would be like x naught, y naught, z naught. It's a point, it's a ray, it's a plane, it's Dr. Gold. What's up? Shout out to Zach. Zach's a great guy. Go say hi to Zach. We love Zach. How do I do this? Shout out. Yes. Oh, and Obi, I need to give you a shout out too. Can I shout out people? Or it's N Simplex? There we go. I gotta wait 20 seconds. 20 seconds. I'll get you a shout out. So yeah. So R naught points to X naught, Y naught, Z naught. And so then this thing, R minus R naught, connects X, Y, Z to X naught, Y naught, Z naught. And that's like a line that connects these 2 points. Okay. Now, that line in the plane has to be perpendicular to the normal vector in the plane. Okay? So this is the normal vector, which is always perpendicular or 90 degrees to the plane. I mean, this is assuming, right, that the plane is not curved, right? I don't know about like curved planes. Probably weird. Okay, so if two things are perpendicular to each other, then the dot product of them is 0. So we say like the dot product. Yes, R and R not on the, but R, yes, exactly, Lynn. Yeah. So I like to think about this. Like this is some arbitrary like origin point, Lynn. And R is a vector that points to a point P in the plane. R naught points to another point P naught in the plane. But subtracting the two gets you a vector that's in the plane. So then the dot product of two like perpendicular vectors has to be equal to 0, okay? So the dot product of n with r minus r naught has to be equal to 0. And this is where this is super cool, right? So n, we then usually write as a vector that's a, comma, b, comma, c. These are the coefficients on my normal vector right here, right? Which we figured out was, right, -4, -7, and 1. And then r minus r naught, this is dotted with x minus x naught, comma, y minus y naught, comma, z minus z naught. And then this is all equal to 0. And then if you remember how a dot product works, you say this times this, plus this times this, plus this times this. Dot products like multiply the corresponding components. So like the first one hits the first one, the middle one hits the middle one, the last one hits the last one, and then it adds them up. So this is why you get a x minus x naught plus b y minus y naught plus c z minus z naught is equal to 0. And that's the equation of a plane, which then works with this, right? That's how we did that. Sebastian brings up a good question, which I think Lynn brought up. And maybe, Zach, you can explain this better, because I don't know much past 3 dimensions. But they say, does this generalize to n dimensions? And I'm tempted to say yes. I'm tempted to say that yes, this would generalize, but the issue of like doing a cross product to find the normal vector does not. So I think finding the normal vector becomes trickier in higher dimensions. Popoli says, still waiting for the next geometry update for them to add W, so it's WXYZ.
My man.
W. Yeah. Yeah, so I think this works. Lynn says you would treat the lines as the spans of 2 vectors. Okay. That's some fancy words that I don't necessarily... I've heard of them, but I'm not... Just looking to 4 dimensions. I don't know how to do like normal vectors in 4 dimensions though. What I am curious though, is if Jeff's original method. Jeff had another method. He said we should just do this. He said we should just do ax plus by plus cz is equal to 1, and then just plug in all these points. Right? So if I plugged in this point, I would have 1a plus 0b. So that would be, right, so 1a plus 0b minus 1z. Sorry, minus 1c is equal to 1. I'd have 0a plus 1b plus 2c is equal to 1. And then I would have 3a minus 1b plus 0c is equal to 1. So now this... What's up, Ethan? Good to see you, dude. This can be generalized into... This is a 3x3 system, right, that we can solve. So I think what you do here is you do 1, 0, minus 1, 1, 0, 1, 2, 1, 3, minus 1, 0, 1. And then we just... I want to say we just RREF this. I want to see if we get the same answer. Let me do this real quick. Second matrix. Edit. 3x4. 1, 0. Negative. Here, I'm going to set the calculator so you guys can see what I'm doing. Sorry, that's... What's up, dog? Yeah, I mailed your Nintendo Switch to, or I ordered it today, so it should be. I'll tell you when I got a tracking number for it. But congrats on winning that, dude.
Thank you so much. I just
Yeah.
want to agree with that I won Nintendo Switch.
You did, yeah, you won. You had a really cool talent show entry too. I'm gonna show people that. You memorized.
Again,
How many decimals of pi did you memorize?
79, and you should have gotten the joke.
79 is the atomic number of gold.
See, and I told you, and I said that in the I made a pun on that at the end.
Oh, did you? Oh shit, I'm sorry if I missed that.
Said awesome. Like remember back in Jackbox things?
Oh, AU. Okay, I see what you said. I got you.
Like that's what I was doing.
Nice. Thanks. Yo, what up, Equity? Good to see you. What's up? Minnie says, yo, dude, just came across your live. Much love. Keep up the great work. Love to see people helping out others. Yeah, fuck yeah, dude. Thank you, Minnie. Appreciate it. Drop a like, drop a follow, all that fun shit. YouTube will connect me with more people, and then we can go take over the world or something.
But just that's a go. I like to say that
What's up?
I will enjoy this very much. I heard your call with my dad as well.
Yeah, I did call your dad. Yeah. Yeah, no. He's funny. He sounds like you, which is fun. I love that.
All right. But yeah, so moving on. Like I haven't posted a good grade in a while.
Okay.
And I just took a mock test last week, Monday.
How'd you do?
By Friday. Like, check out grades if you want. I have it right there right now.
Let me go check good grades real quick. Yeah, so what we do is we also reward students for doing well, like in their good grades. And 1 second, let me get the calculator off the.
And it's a test, by the way. It's a test. It's a
Oh,
test.
this is a test. Okay, good. 1 sec. I gotta move my mouse somewhere. Okay, there we go. Let me get the calculator off. Oh, I have too many things. Nice. Oh, this is your math test? Oh, wow. Is this all correct? Does this mean you got it all right when your teacher puts like red lines through things? Oh, yeah, 25 through 25. Nice, dude. Good job.
I'm up here. I'm trying to do the best I can. I'm in my prime right now, okay? 2025 is my prime year right now.
Hell yeah, dude. I'm down the prime year.
And also, there is one thing. I study, well, if I could get like 3 minutes for help, then it will be all right. But it's
okay.
Like, do you know in computer science, like decimal and hexadecimal?
I do know hex. Yeah.
The thing is that I have a test based off the fundamentals of computers, and I have to know that conversion, but I'm just somewhat confused.
Okay, I'll help you out with it. Drop a screenshot of something, or I can. Let me help out. I gotta help Nick out next because he's been waiting patiently, but I will do it. Cool.
All right.
Nice. Okay. All right. Let me see. So.
And then just ping me when it's time for me, and then I'll find a way to.
Yes. Yes. We'll do. Let me see what Lynn's saying. Span is like the linear combination of a space, so every scalar multiple of a case of vectors and a span and two independent vectors must give a subspace. Okay. So if you have two vectors that lie on a plane, the combination of them must also lie on a plane. Oh, okay. I think I see what that means. Okay. So if you can like group two things by something, you're saying that then they must also lie in it. We're going to do yours next, Nick. I'm going to do yours right after this. Also, let me give a shout out to Obi. I appreciate Obi for rating earlier. Go check him out. He's cool. Okay, so, yeah. So, Jeff, your method did work here, dog. So, if I did this, right, and I did the RREF, a matrix is like a collection of numbers. It's like a structure. You get this, which if I multiply through by 5, look at that. 4x plus 7y minus 1 is equal to 5. That's the same answer we got here. So that's actually super dope. Wow. Okay, cool. Oh, so yeah, minus z. Sorry, not minus 1. Sorry, minus z. Thank you. That's super cool, Jeff. Okay, so I think this is the more rigorous way to do it in terms of like vector calculus. But if you want to start diving into linear algebra, you can just always set up a whatever by whatever systems of equations, and then you can do row reduced echelon form, or what they call it, like Gauss-Jordan elimination, in order to figure out your equation. That's so cool. So Lynn, I think that's a way to do it at like infinitely higher dimensions, is to just set up a big massive matrix and then just solve it that way. Learning stuff all the time. Anyways, that's cool. Nice. All right, good question there. Thank you, Odin Root. I appreciate it. Okay. Nick, let's help you out, Nick. Where you at? Come on in. Let's help Nick out with some questions. When adding the jump scares to live, maybe Halloween. I do have jump scares on my gaming channel. I don't know if I have them on this one. Where's Nick? Also, I need to fix this. I don't have the vanity URL for this. Discord.gg/actualGDO. Nick went to Nickelodeon. He just asked me if like we would have time for his questions, and like now he's not here because I gotta go in a bit. There you are, Nick. There he is. Okay, Nick, can you hear me? Yes, you can. Okay, awesome, cool. Okay, cool. Which question do you want to do? You can talk in a sec. Okay. Do you want me to just do Ethan's like hex question first, and then we can do yours? Wait, 28 boosts? Wait, you can get even more boosts in this? Server tag badge packs? Dude, Discord needs to chill, dude. What? They're just like trying to get us to spend so much. I already spend so much on boosts in this server. What the fuck? There are badge packs now? The flex badge? Dude, this is gross. What? Discord needs to chill with this, dude. No. Oh my god. Discord. Stop. What's happening to Discord? Okay, can you talk now, Nick? Do you want to work with you? Do you want to work on one?
Yeah,
Yes?
Can you hear me or no?
I can hear you, dude. Yeah, you're good.
Okay. Yeah, because I'm in a restaurant right now. I went to the bathroom.
Oh, I'm all right. So live from Nick taking a shit.
I wish. I really need to use the bathroom.
All right. Let me find your messages though.
How many can we go through?
3.
Okay. Yeah, because I can only come at least like 1 or 2 or 3 more times, and that's it. 1 or 2.
All good. Here, let's do these 3. Okay. Questions 18 to 25 would be answered on the basis of the following chart. What is the final cost to obtain an index number, demand a jury trial, and file a notice of appeal? Is that just adding the numbers?
Yeah.
Hustler, chill spamming my fucking chat, please. Oh dear. I gotta go take care of someone spamming my chat. Hold, please.
You will get number 18 wrong. You'll understand what I mean.
I gotta put you in timeout, dude. I gotta put you in timeout, Hustler.
Bro got the ban hammer. Ban his ass.
Can't just be spamming shit in my chat, dog. Please don't do that. Okay. All right. So, just adding these up. Obtaining an index number is $210. So, okay. Plus anything else, dude, right? So, you don't even need to, like, read any of this, dude. Because this number is more than 210. Or less than 210, sorry. So, it can't be that cheap. It can't be that cheap. And it can't be just 210 because you also have to do other stuff. So, I don't even need to add the numbers, Nick. You just go right away to this. You need something that's... Yeah, you just need something that's greater than... You just need something that's greater than 210, right?
No, you have to do the index number and the notice of appeal.
Yeah, but what also like demand a jury trial, right? Yeah. But I'm saying,
Yeah,
Nick, as a test taking strat here, you know it's going to cost at least 210 because you need to obtain an index number, so that gets rid of choice B and choice C because those are less than 210. Right. And then you also know it's something more than 210 because you also have to do this other shit which costs money. So you can get rid of the 210, so it just has to be answer choice D. Jeff says it adds up to 340. Oh, that's problematic, dude. What?
That's what I'm saying.
Okay, so that's 65. Demand a jury trial is also 65. Yeah, that is problematic.
Yeah.
Well,
That's
okay.
what I'm saying. You're gonna get it wrong.
Well, they said the answer was D anyways. It's a typo. It's a typo.
Yeah.
Okay. What is the final cost to obtain an RJI and note of issue? So that's 95 plus the note of issue. So that's 125, right? That's easy. Yeah. Which of the following is most likely to be filed with an RJI? Well, I don't know. What the fuck do you answer that, dude?
It all is one by one after the other. So the first one you have to do. You're doing
it's sequential. So you can't do this until you do all the stuff beforehand. Okay.
Probably.
Oh, so yeah, the answer is D, obtaining an index number. Yeah. Nice. Okay, I can do the next 3 on those. Because that was pretty quick.
I think the next 3 is for this one.
It still is, yeah. Here we go.
Yeah.
Which of the following is most likely outcome of filing a voluntary discontinuance? Well, most likely would be anything before it, right? But actually, where does this come from? Where do you get these answers? I feel like this has to be known like outside of math. They say the correct answer is B. They say the correct answer is B. Portfolio says, what the fuck? This is bro learning to be a lawyer. Bro's learning to be a court officer is what he's doing.
Yeah.
Okay. I don't know how to do 21. That's just like a look it up. What's the final cost of filing a notice of appeal? Oh, I see. The final cost of filing a notice of appeal. Is it all of these things? Do you have to do all of these and then do this? Because that seems like a lot of money.
No, it's everything before it.
Right. Which is a lot of money. That's like none of those numbers. I'm tempted to just say it's just 65 because that's what it says.
Wait, what is the final cost? Oh no, it's just talking about the 65.
Oh, okay, easy. Okay, what's the final cost of all items prior? Dude, it's this, right?
Yeah.
Because I mean, there's no way it's less. It's no way it's less than 65, and there's a ton of other shit that costs a lot of money. So plus the 210. So yeah, by process elimination, you know it's this. Cool. Okay. Nice.
Number
Good job.
21 is dismissed because if you file for a voluntary discontinuance, the case is dismissed.
Oh,
You
okay.
discontinue the case.
Okay. Can you like
Yeah.
discontinue the case and then you can file another appeal?
Yes, but you would have to
Okay.
pay for the discontinuance.
Yeah. Our legal system's fucked, dude. Okay, cool. Good job, man.
Yeah.
All right, let me help out Ethan. Then I gotta go. And here I'll send this to you, Nick.
Thank you. I gotta go because somebody's waiting for the bathroom.
No legal system, illegal system. Yeah, I thought that was double jeopardy. Yeah, right. All right, Ethan, what's up? Let me tag Ethan. Then I gotta rock a roozies after this. And let me get you a bond coin, Nick. You're right. Okay. Decimal and hexadecimal. Okay, I'm glad, Nick. Okay. So hex. So decimal goes deci, right? Deci means like up to 10, right? So in regular decimal system, you have 0, 1, blah, 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 all up to 9. So that's 10 different numbers, right? Because if you're counting the 0. So yeah, Jeff has just, and so how that works, right? Is that this place like determines like 0 to, this is what we call like the ones place. Then this is the tens, and then this is the 100s. Well, actually, it's the other way around. Sorry. Let me do it this way. Sorry. This is the ones place. This is the tens place, and this is the 100s. Okay. So if you wanted to write out, I don't know, like, yeah, 343, right? So for instance, or let's just look at 528, right? That's 5 100s plus 2 10s plus 8 1s. You're welcome, Nick. Yeah. So that's how, this is how numbers work in decimal. Okay. Hexadecimal works different. Hex is base 16. Okay. So you have something times 16, something times 256. Yeah, power position. Oh, and then something times 1, sorry. Sorry, this is what I meant to say. And the way it works, right? This is like 16 to the 0, 16 to the 1, 16 to the 2. This is like 10 to the 0, 10 to the 1, 10 to the 2. Right, exactly. So, yeah. With hexadecimal, you want to see what's the biggest number I can put into it. What is 16 to the 3rd? $4096. Okay. Okay. So this is obviously smaller than 4096, so we don't need this last decimal. Okay. So I can see how many 256 can I put into there. I can put 2 of them, right? So I know 528 is equal to, this is going to be 2 times 256, because that's going to get me 512. Okay. And then how many 16s do I want? So what's left over, right? So then 528 minus 512 is going to be 16. Oh, that's beautiful. So there's only one 16. And then there's 0 of the ones. Okay. So then, yeah, in terms of hex, and how we write hex is you write like a 0x. This means like hexadecimal. And then you have digits here, right? So then this would be 0x. And I think this would be 210. Yeah. Yeah. You want to start with the biggest number, Poi Poli. Let me make sure I have that right, because then it's like, what base is it? And here I can put the fast one. Right. So it's OX210. Yeah, nice. Okay, cool. Cool. It didn't do the LaTeX correctly. Yeah. Yeah, good. Okay. Yeah, did I do this wrong then? Sorry. I think the remainder is... Sorry. 5... So 528... Oh, wait. 528 divided by 16, you get a quotient of 33. Remainder 0. Then you divide the quotient by 16, you get 2. Oh, okay. And then you divide by remainder 1. Now you can't divide anymore. Oh, I see. You just keep dividing by the base? Oh, that's really cool. Oh, I think that's really cool, actually. Okay, whoa. Ooh. So what happens if you have a remainder, though, right? So you say divide by 16 gets you 33. And then you do 33 divided by 16. And that gets you 2. And then the remainder is 0. Oh, okay, 2 remainder 1. And then sure, and then you can't divide. And then okay. So then 1 divided by 16 is 0. So 210, is that how that works? That's actually really interesting. Omega says, I learned it when kiddo from the most feared high school book, Algebra, by Cuban professor Aurelio Baldor. Just say Baldor to any Latin American 40 plus or you'll get horror stories. Oh, sorry, it's 2 divided by 16 is 0. What's up, Marlia? I actually just have to leave right now, Marlia. I apologize. Well, let me see. I'm supposed to meet someone up. One sec. $33 remainder 0. Okay, one sec. 33 remainder 0. 2 remainder 1. And then you get 0 remainder 2. And then do you go backwards? Is that what you do? Then you do 2, 1, 0. Is that how this works? Oh, very cool. All right, let's try this trick with this then. Okay. 761 divided by 16. Or actually, let me pull my calculator. So 761 divided by 16. Good luck on your test, Maria. That's gonna be 47. And then, so I do 47 times 16. So that's gonna be remainder 9, right? So then I do 47 divided by 16. That's gonna be 3 remainder 1. 3 divided by 16 is 0 remainder 3. So then the answer should be 319. That's super cool if this works. Oh, 2 remainder 15? Sorry, what? Oh, you're right. I fucked up. Sorry, I saw 47. I'm like, it's so close to 48. Just give it to me. Yeah, my bad. Okay, 47 by 16 is 2 remainder 15. Yes, okay, I agree with that. Okay, and then 2 divided by 16 is equal to 0, remainder 2. So then it's 2. Hex for 15 is 9, A, B, C, D, E, F. What is it? 10, 11, 12, 13, 14, 15, F. So it's 2F9. 2F9? Yeah, this is the other cool thing. So for numbers greater than 10, you have to start using the alphabet. Or greater than or equal to 10, I should say. So, let's see. Now do 761. 2F9. Okay, I do have to run. But, okay, cool. Good job, everyone. Glad we got that right. Let's close out the stream. Thank you, everyone, for coming to Actual Education Office Hours. Really appreciate you guys coming in with all the questions, all the fun stuff. You guys are awesome. Our next stream will be tomorrow. It's going to be an hour later, 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Come on through. Ask whatever homework questions you have. Or if you just want to, like, learn some new stuff with us, I'm totally down to, like, go through it and explain it to the class. It'd be super cool. I see some people submitted some, like, kind of, like, at the end here. Come by tomorrow. I'll go through these. But yeah, great stuff. Clap, clap, clap. Yes, thanks, Omega Kent. That's a very cool trick. That's a super dope trick. I didn't know that trick with Hex. Or like any base anything. That's really cool. Okay. That being said, let's go raid somebody. We're gonna go raid. Got a bunch of people on Twitch here. Concave up or concave down? Ooh, I like saddle. Saddle Fetty Wap, dude. Saddle. Okay. Not many people stream on Mondays. We got to get more of you guys streaming on Mondays. I don't know if I want to throw us into politics. Politics are pretty fucked right now. But no one else is on. Okay, cool. All right. Go say hi to Zach App. He's a cool guy. I've talked to him before. All right, cool. All right. We'll see you tomorrow. Enjoy. Fetty Wap. Come to my stream tomorrow. That's going to be at around this time tomorrow. I'll help you out, Precock. We will see you tomorrow. Enjoy your Monday. Great start of the week. Peace.